Hey y'all, my name's Billy Buck from the Deep South.
My name is Boulder from Colorado.
And my name is Vladimir. We are Team Extreme.
Yee-hee!
Yeah, we're extreme.
Really extreme.
The most important parts of being extreme is having knowledge of physics concepts.
Boulder, you are a big nerd. But really, we understand that if we want to be extreme, we have to be able to react quickly to danger.
Danger's my middle name.
Response time is the period of time that elapses between when you see a danger and when you react to it.
In our case, that time is very quick, like cheetah.
Unless we're tired, distracted, or otherwise loopy.
When we are biking, because we're extreme, we never distract ourselves, and this allows for us to have a quick reaction time.
When there is babushka in the road, this matters because when they brake hard, we do not hit.
We usually give ourselves a distance we cover in 3 seconds between the car in front of us.
Which is known as the 3-second rule. Vladimir, can you tell us what safe following distance is?
Well, safe following distance between you and the car ahead of you is that which allows for enough time to react and avoid a collision if something happens to the car ahead of you.
Great, be safe, kids.
Also, when you follow too close to car ahead, it is tailgating.
Bad.
So, to avoid tailgating, follow the 3-second rule.
Billy Buck, what is safe stopping distance?
Stopping distance is the distance traveled between the moment you realize there's danger and when you stop.
And what is reaction distance?
Reaction distance is traveled in the same period of time elapsed when you recognize a danger and when you put your foot on the brake.
Then what is the braking distance?
That is distance car travels once the brakes are applied to when it comes to a complete stop.
Oh, so if you add the reaction distance and the braking distance, you get a total stopping distance, right?
That's right.
If you add the reaction distance and the braking distance, you get a total stopping distance.
So, if I go faster, how does that affect my stopping distance?
The faster you go, the longer the reaction distance and the braking distance are.
Which means the stopping distance is longer too.
What would happen if someone's reaction time was longer?
Well, if Boulder takes longer to react to the babushka, then the reaction distance is longer, and the braking distance remains the same. However, this still increases total stopping distance.
So I would run over that poor babushka?
Probably.
Boulder, can you explain the purpose of the yellow light?
Yeah. Yellow light warns the driver that the light is about to turn red.
How do you know to go or not when light turns yellow?
Well, if you are in the go zone, then you are safe to continue through the intersection.
And what is the go zone?
The go zone is a distance back from the intersection that allows the car to make it completely through before the light turns red.
What is stop zone?
Well, Vlad, The stop zone is the distance away from the intersection where it is possible to come safely to a complete stop before the beginning of the intersection.
But Boulder, what about the space between the go zone and the stop zone?
Wouldn't that be called a dilemma zone?
Yes, the distance between the end of the go zone and the beginning of the stop zone is a dilemma zone. This is a very tricky spot to be in.
There is actually no such thing as dilemma zone in real life. It doesn't exist because traffic engineers' job is to make sure intersections are safe and don't have dilemma zones.
Wait, I know there can be a gap between the go and stop zone, but what if they overlap?
Well, then that's called the overlap zone. It means that during that area, you can either continue through the intersection or stop and be completely clear of the intersection by the time the light turns red.
What if you're in the overlap zone?
Well, since the overlap zone allows for either the choice to stop or go, then it is actually up to you. If you are unsure, it is always best to stop.
Billy Buck, what are some other physics concepts that we have not covered yet?
Well, Newton's first law states that an object in motion stays in that same motion until acted upon by an outside force, and an object at rest stays at rest until acted upon by an outside force.
Sunday, Monday, happy days. Tuesday, Wednesday, happy days. Thursday, Friday, happy days. The weekend comes, my cycle hums, ready to race to you. These days are
Another name for that is inertia.
What about Newton's second law?
His second law is that force is equals mass times acceleration.
And Boulder, what is momentum?
Well, momentum is calculated using the formula momentum is equal to mass times velocity.
What does it mean?
Momentum is quantity that describes object's resistance to stopping.
What about impulse?
Impulse equals force times time.
What does it mean?
It describes the effect of the net force acting on an object.
Also, what is pressure and how does it relate to our video so far?
Pressure is amount of force per square unit. Pressure is everywhere, on objects on the table, or even cars on the road, and the majority of pressure is that which is due to gravity.
What is centrifugal force?
Wow, you dum-dum. There is no such thing. The correct term is inertia.
So, we already found out that inertia is the tendency of an object to stay or move in a continuous motion. But, how is that related to a vehicle with a curve?
Well, with curve in road, inertia make car want to continue going straight instead of turning.
If you try to turn too fast, then you can catch an edge and the vehicle will flip over.
If cars can't go fast around turns, then how are there turns in the road?
Well, with turning road, there are banks to turn. This allows for the vehicle to be able to fight the turn better without totaling the car.
If there is a bank on a turn, then the gravity is helping the car fight it because the gravity is pulling down towards the inside of the turn, and this keeps the car on the ground and in the lane.
Why is it called acceleration when going around a turn but my speedometer reads 25 miles per hour the whole time.
Well, that is because acceleration is not based on speed.
Yeah, acceleration uses velocity, not speed.
So if velocity is the speed of something in a certain direction, then when you go around a turn, the car is changing direction, not speed, but the velocity is changing.
Yes, which makes acceleration change.
How does friction play a role in these physics concepts?
Well, with the more friction, there is more grip on the road. So when you go around a bank turn, you don't slide in the direction that inertia wants you to take. You grip the road and you are able to turn.
Yes, imagine turning on ice in the middle of Mother Russia. You would not turn because there is no friction and you would stay going in an original direction.
Yeah, it's like trying to turn on ice skiing down a mountain. It's not easy.
What is centripetal force?
Centripetal force is force that makes object following curved circular path if it is connected to something centrally located that is stationary.
So how does that relate to driving?
Well, since centripetal force is a center-seeking force, and the force is directed toward the center of the circle, that force keeps the car on the road, instead of in the ditch.
However, the faster object is moving, the more inertia fighting against the centripetal force, and the more dangerous it can be.
Be safe, kids.
How does speed and turn radius affect your driving?
Well, faster you go around turn, the more likely you will crash.
Smaller the radius is, the slower you must go because the inertia for smaller turns is larger.
There is actually no such thing as a dilemma zone. No, I can't even do it.
That's definitely Jamaican.
No, I know, I was trying to be at the end.
Oh my god, this thing is so hot.
Alright, so what else do we need to set
Oh, I
up?
should probably shut the camera off first.
Yeah, that's probably a good idea.
Mother Russia. Hey!
Just turn it off.
Sunday, Monday, happy days.